Section 20.7, Igneous Rocks. So most rocks, if you were to somehow push them below the Earth's surface, the high pressure and high temperature there is going to keep the rock from melting. Instead, as you push those rocks down, or as you go down into the surface of the Earth, you find that you have what is kind of like an elastic solid of rocks. Think of it kind of like the surface of the Earth floating on jello, if you will. It's an elastic solid. It can bend and stretch, but it's still solid. Here you have places where cooler, more dense rocks are going to sink to the bottom, and warmer, less dense rocks will float to the top. As those cooler rocks sink to the bottom, they heat and expand, and as the less dense rocks float to the top, they cool and they contract. This forms a convection current inside of the Earth that moves the surface of the Earth around. As these rocks are there, some of them will melt and they form magma. If you add water to that particular situation, then it's easier for the rocks to melt. It can lower the melting point and you can generate more magma. You can also generate magma when you have magma that comes in contact with solid rock. It can cause it to melt. It can heat up the rock, cause it to melt, and then cause it to recrystallize or reverse the crystallization process. And it does all of this based on the temperature. And so when you have magma melting and cooling like this, it changes the composition, and you can get a variety of different types of igneous rocks. So we have three types of magma that occur in three particular geological settings, and they have varying silica concentrations. And so we have three major types of igneous rocks. Basaltic igneous rocks, which make up about 80% of the Earth's magma, and then andesitic magma, and then granitic magma. And these make up or account for the types of igneous rocks as well. Igneous rocks at Earth's surface, we call those extrusive igneous rocks or volcanic rocks. They're formed from the eruption of molten rock at Earth's surface, from magma coming up from the Earth's surface through something like a volcano. And when magma does that, we call magma lava. Lava is just magma that's reached the Earth's surface. It can escape through fissures in the Earth, so volcanoes, or it can escape through boundaries between plates in the surface of the Earth. Most lava production occurs along the ocean floor, but you can also have fissures, breaks on land, and obviously you can have volcanoes on land. Volcanoes are just vents where you have magma that rises to the surface, and we can have three different types of volcanoes, basically just determined by their shape and their size. The first is a shield volcano. Generally has a steady supply of lava, a very broad sloping cone, a very broad volcano. Then you have cinder cone volcanoes that are very steep, but are generally around one really small area or a single vent. And then you have what are called composite cone volcanoes, which are kind of a mixture of the two, but have one steep region and one generally slow, broad sloping region. When we have igneous rocks that are beneath Earth's surface, we call those plutonic or intrusive rocks. Intrusive igneous rocks are called plutons. And the most common plutonic rock is granite. And here you can see pictures of the different types of volcanoes. Here you have the shield volcano with the broad slope, and then the cinder cone volcano that's very small and takes up one little region over one vent. And then you have a very broad sloping but still narrow vent of a composite cone volcano.